Hi, Assalamualaikum. My name is IZZAIRIL bin Ismail. My matrix number is A22A0811. So I will talk about data description. Our group has been given data A and we choose cylinder, total engine cylinder for each vehicles as our variables. The most common configurations number of cylinder is being 4, 6 and 8. And that is the reason you can find these three figures in our sample data. From the 393 observations, we just use 150 observations which were randomized by IBM SPSS Statistics. The data from EcoDrive website state that 4-engine cylinder is the common use in nowadays vehicles, and we decide to running our test to see if it's true or not.
Hi, I'm Siti Aisyah Binti Ismail and my matric number is A22A1188. Now I will explain about sampling data and record categorical data. From all the categorical data in our study, we choose one numerical data which is the total engine cylinder for each vehicle, G cylinder. Therefore, in this research, we study 150 observations and one category to examine and determine vehicle fuel consumption. The data can be shown in this table.
Assalamualaikum and hi, my name is NURUL binti AMIN and my matric number is A22A0914. I will explain about 3.0 numerical descriptive measures for ungroup data, which is cylinder that our group have chosen. 3.1 Measures of central tendencies. There are three most commonly used measures of the tendency for ungroup data, which is mean, median and mode. As you can see in this slide, this is the table to get mean, median and mode. For the mean, sum of the data entries must be divided by the number of entries, which is 1081 divided by 150, and the mean of the cylinder is about 7.2067 cubic centimeter. Next, 8 is the median of the total engine cylinder. To get median, 8 must plus 8 and divided by 2. And the mode of the cylinder is also 8 because it have the highest frequency, which is 96. 3.2 Measures of position. After my calculation, quartile 1 is located at 37.75th position. Therefore, the position of the first quartile is located at class interval 6 by observing the cumulative frequency value. This means that 25% of the total cars in the data use a total of 6 engine cylinders. Meanwhile, quartile 3 is located at 113.25th position. Therefore, the position of the third quartile is located at class interval 8 by observing the cumulative frequency value. This means that 75% of the total cars in the data use a total of 8 engine cylinders. Lastly, 3.3 Measures of variation. A set of random variables degree of variation can be measured using 3 parameters, which are range, variance and standard deviation. To get the range, maximum data entry minus minimum data entry. The maximum and minimum data entry for cylinder is 8 and 4. So, 8 minus 4 equal to 4. So, the range for cylinder is 4. Next, the sample variance for the cylinder that I get is 1.252. And lastly, to get the standard deviation, square root the answer of variance, and I got 1.119 for the standard deviation of total engine cylinder.
My name is AQIELAH binti ZAHARIMAN. My matric number is 22A0318. So I will continue with the graphical representation. We use histogram. A histogram is a type of bar graph that displays the distribution of data value. It presents a graphical representation of how frequently each value occurs with each of data. A histogram is composed of many stages. First of all, the quantitative value of the data are displayed on x-axis, either at the middle or at the limit of each class. On the y-axis are the frequency or percentage of the data for each class. The bar in the histogram should start and end at the class boundary rather at the limit of the class set. Also, the bar must be near one to each other. So, from this histogram, prove that the graph is labeled along with x-axis with the class, beginning at the first class at 1 with a frequency of 0 and ending at the last class at 8 with a frequency of 96. Since the class 8 has a larger frequency compared to other class, we may therefore deduct that is the highest cylinder. Besides, class 6 has a lower frequency of 1 than others.
Assalamualaikum and hi. My name is PUTERI NADIA. My matric number is A22A1236. Next, I'm gonna explain about Part 5 Statistical Analysis using software. The statistical analysis for the parameter of the number of cylinder, the calculation result was compared between the use of SPSS and manual calculation. Overall, the result of calc using SPSS and manual calc shows similar overall statistic. In calculating the mean, there is a very little difference in the mathematical value. Specifically, the average is 7.21 in SPSS and 7.2067 in manual count, showing a difference of 0.0033. Meanwhile, the calculation of mean, mode, standard deviation, variance, range, minimum and maximum show the same result. Likewise, the quarter percent value on both methods show similar value, with the first quarter of 6 and the third quarter of 8. Overall, the comparison between the result calculated using SPSS and manual show a high consistency in provide similar statistics for each measurement parameter, confirming the reliability of both methods in producing consistent statistic analysis. The graph above shows the relation between class on the x-axis and frequency on the y-axis, used to visualize the spread or distribution of data in a dataset. The total frequency must equal the sample size, which is 115 of the dataset. Concluding a t-test with a signification level alpha of 0.05, the null hypothesis HO was stated as the equality of the mean μ1 equal to μ2 between two groups categorized by the number of cylinders, 4 to 6 cylinder and 7 to 8 cylinder. The alternative hypothesis HA was formulated as the mean begin not equal. The statistical analysis was performed using SPSS, providing group statistics for both categories. The t-test result indicate a significant difference between the means with a t-value of 8.188 and a p-value less than 0.05, supporting the rejection of the null hypothesis. The decision rule based on the critical t-value of 1.938 lead to the rejection of HO. Therefore, it can be concluded that there is a significant difference between the population mean of the two groups, suggesting that the number of cylinders has a meaningful impact on the variable under consideration. The analysis of variant ANOVA conducted for the variant cylinder, the null hypothesis HO posited that there is no difference in mean among the group, while the alternative hypothesis H1 suggests that at least one mean group mean is different. The significant level alpha was set at 0.05. The output from SPSS provide the necessary statistic for ANOVA, including the F value. The decision rule certified that the null hypothesis will be rejected if the calculated F value exceeded the critical value. F 0.05 sees 143 equal to 2.165. In this case, the calculated F value was 17.952, surpassing the critical value, leading to the decision to reject the null hypothesis. Consequently, it was concluded that there is a significant difference among the treatment mean for the variable cylinder. This implies that at least one group mean is different from the other, indicate variable in the number of cylinders across the group being compared. The correlation analysis conclude between the variable cylinder and KPI km per liter. The null hypothesis has zero state that there is no significant correlation between the two variables, while the alternative hypothesis H1 proposed that there is a significant correlation. The significant level alpha was set at 0.05. The output from SPSS relieved a percent correction confidence of negative 0.558 between cylinder and KPI with a corresponding 2-time p-value of 0.000. Since the p-value was less than the significant level, the decision rule dictated that the rejection of the null hypothesis. Therefore, it was concluded that there is a significant negative correlation between the number of cylinders and full effective KPI. The negative correlation indicates that as the number of cylinders increase, full effectively tend to decrease. This supports the idea that change in the number of cylinders are related to change in kilometer per liter.
Thank you, Farrah, for the input. Hi, my name is Aisyah Binti Ismail, and my matric number is A22A1188. Now, I will explain the next part, the confidence interval. Confidence interval refers to evaluating the interval of statistic containing a population parameter. According to the table, we have 95% confidence that the mean score of the total engine cylinder for each vehicle will fall between 7.03, the lower boundaries, and 7.33, the upper boundaries. Next, I will discuss about prediction modeling. Multiple linear regression is the most common form of regression analysis. It allows us to use several variables simultaneously to explain the variation in a continuous dependent variable. Hence, the model is represented as the picture above, where y is dependent variable which is cylinder, B1, B2 or Bk are parameters which is kpl and horsepower. The objective of the regression is to test the influence of travel distance, kpl, and total horsepower for each vehicle towards the cylinder, total engine cylinder for each vehicle. This is our hypothesis for the multiple linear regression, and this is the scatter plot metric between cylinder, kpl, and horsepower. Next is the correlation analysis. The correlation tables show the Pearson correlation between cylinder, kpl, and horsepower. The table shows that the kpl is correlated with the cylinder at negative 0.629 below 0.3. Hence, it shows that the total engine cylinder is not associated with the car's travel distance kpl. Next, the horsepower of vehicles is correlated with the cylinder at 0.745 above 0.3. Thus, the total engine cylinder is associated with the horsepower of a car. However, the R value between kpl and horsepower is negative 0.691, which is less than 0.85, meaning that there is no problem of multicollinearity. Hence, the model is represented as the picture above, where y is dependent variable which is cylinder, B1, B2 or Bk are parameters which is kpl and horsepower. The objective of the regression is to test the influence of travel distance, kpl, and total horsepower for each vehicle towards the cylinder. Okay, now the ANOVA table. The p-value from the ANOVA table is less than 0.001, which means that at least one of the two variables, kpl or horsepower, can be used to model the cylinder. Next, coefficients. In order to implement the value into this equation, we use the value from understandardized beta coefficient, where x1 is kpl and x2 is horsepower. Thus, for every unit increase in travel distance, kpl, the total engine cylinder will drop by 0.065, provided the car's total horsepower remains unchanged. Similarly, for every unit increase in the total horsepower, the total engine cylinder will increase by 1.766 units, provided the car is still at the same travel distance, kpl. Based on the standardized beta coefficients, the effects of horsepower is 0.595, which is about 2 times higher than kpl. In addition, the 95% confidence interval for kpl is negative 0.109 and negative 0.21, and the confidence interval for horsepower is between 1.333 and 2.199. This indicates that both parameters are significant to cylinder, as the value of 0 does not fall within the interval. Furthermore, the zero-order correlation value for kpl is negative 0.629, which is less than 0.3. It shows that the partial and part correlation between cylinder and kpl is very small in magnitude. However, the partial and part correlation between cylinder and horsepower is very high in magnitude, as the zero-order correlation value for horsepower is 0.745, which is more than 0.3. Other than that, the VIF values are below 5, which is 1.914, indicating that there is no problem with multicollinearity. And lastly, the graph. Below are the graphs that can be used to describe multiple linear regressions between cylinder, kpl, and horsepower. So that's all from me. Thank you for listening.
As conclusion, I can simplify that the mean for this data set is 7.2067 cm square, and the median and mode for the data set is same, which is 8. The position for the first quartile is located at class interval 6 and the third quartile is located at class interval 8. The range is 4, the variance is 1.252 and the standard deviation is 1.19. By using the histogram method, we can say that the largest frequency is 8 while the lowest frequency is 6. Examination of the mean statistic through SPSS and manual calculation shows that the result is 7.21 and 7.2067 respectively, while the result for median, mode, standard deviation and variance shows the same figures for both methods. It also goes same for the range, maximum and minimum value, position for the first and third quartile. After doing all the tests and hypotheses, all results lead to the rejection of H0. And lastly, we choose kpl and horsepower as the other variables, and the result that came from the calculation shows that at least one of the two variables can be used to model the cylinder.